Zoo enrichment revolution, the science behind happier animals. Picture this. You're watching a tiger at the zoo, and instead of pacing back and forth like you'd expect, it's actually solving puzzles, playing with high-tech gadgets, and making choices about its own day. Sounds impossible, right? Well, here's something that's going to blow your mind. That tiger might actually be living a better life than its wild cousins. I'm not kidding. Scientists have discovered that 84% of mammals in modern zoos actually live longer than they do in the wild. And get this, when given the choice between free food and having to work for it, animals choose to work for it every single time. We call this contrafreeloading, and it completely flips everything you thought you knew about animal happiness on its head. Look, I know what you're thinking. You've probably heard all the debates about zoos, seen those heartbreaking videos of animals looking miserable, and wondered if keeping animals in captivity could ever be truly ethical. And honestly, those concerns are completely valid. But what if I told you there's a revolution happening behind the scenes that's changing everything? What you're about to see will completely transform how you think about modern zoos. We're talking about orangutans painting masterpieces on iPads, elephants solving complex engineering puzzles, and big cats that have perfume preferences. Yes, you heard that right. They actually prefer Obsession by Calvin Klein. We'll dive into the cutting-edge science that's proving enrichment isn't just nice-to-have entertainment for animals, it's literally rewiring their brains, boosting their immune systems, and turning conservation success stories that seemed impossible just decades ago into reality. Trust me, by the end of this video, you'll never look at a zoo the same way again. Now, before we dive into all those incredible examples I teased earlier, we need to understand something crucial. This is not just zookeepers being creative or trying to make animals happy for the sake of it. What we're talking about here is hard science, backed by decades of research that has fundamentally changed how we understand animal minds and what they actually need to thrive. Let me start by clearing up what enrichment actually means, because most people think it's just toys for animals. That couldn't be further from the truth. When scientists talk about environmental enrichment, they are describing a comprehensive system built around 5 distinct categories that work together like pieces of a puzzle. First, you have environmental or physical enrichment. This is about changing the actual space an animal lives in. Think climbing structures that mirror natural habitats, or water features that allow for natural swimming behaviors. Then there's social enrichment, which recognizes that many animals are deeply social creatures who need interaction with their own species, or even other compatible animals. Cognitive enrichment challenges their problem-solving abilities and keeps their minds active, while sensory enrichment stimulates their natural senses through sounds, smells, textures, and visual elements they'd encounter in the wild. Finally, food-based enrichment transforms the simple act of eating into the complex foraging behaviors that would occupy hours of an animal's day in nature. But here's where it gets really fascinating. And this is something that completely changed how I think about animal intelligence. The human brain isn't the only one that grows and adapts based on experience. Recent neuroscientific research has revealed that environmental enrichment literally reshapes animal brains at the cellular level, and the results are nothing short of remarkable. When animals engage with enriching environments, their brains start producing more neurons throughout their entire lives, a process called neurogenesis that scientists once thought only happened during development. But it doesn't stop there. The connections between these brain cells, called dendrites and synapses, become more numerous and more complex, creating richer neural networks that enhance everything from memory to problem-solving abilities. It's like the difference between a simple roadmap and a sophisticated GPS system with multiple route options. Even more impressive is what happens with brain chemistry. Enriched environments optimize the balance of crucial neurotransmitters like dopamine and serotonin, the same chemicals that regulate mood, motivation, and well-being in humans. They also boost production of something called brain-derived neurotrophic factor, which is essentially fertilizer for brain growth and health. The result? Animals in enriched environments show measurably better spatial learning, enhanced memory retention, and superior problem-solving skills compared to their counterparts in barren environments. Now, this is where the science gets really mind-bending, and it ties back to something I mentioned in the intro. There's this phenomenon called contrafreeloading that completely defies what you'd expect from basic economics or survival instincts. Picture this scenario. You place an animal in an environment where they can get identical food in 2 ways, either for free from a bowl or by working for it through some kind of puzzle or challenge. Logic tells us they should choose the free option every time, right? Save energy, get the same reward. But that's not what happens. Study after study, across dozens of different species, shows that animals consistently choose to work for their food even when identical free food is sitting right there. This was first documented by researcher Glenn Jensen way back in 1963, and it's been replicated countless times since then. We're talking about everything from rats and pigeons to primates and big cats. They all demonstrate this preference for earned rewards over free handouts. This phenomenon reveals something profound about how animal minds work. When animals engage in goal-directed behavior like foraging or problem-solving, they're not just getting food, they're gathering crucial information about their environment, experiencing the neurochemical rewards of anticipation and discovery, and exercising control over their circumstances. That sense of agency and control turns out to be absolutely fundamental to psychological well-being, not just in humans, but across the entire animal kingdom. The science is so compelling that it's now driving professional standards at the highest levels. The Association of Zoos and Aquariums, which accredits the top-tier zoological facilities in North America, doesn't treat enrichment as optional anymore. It's a mandatory requirement for accreditation, recognized as essential for optimal psychological and physiological well-being. This is not some feel-good policy. It's based on rigorous scientific evidence that shows enrichment is not just nice to have, it's necessary for healthy brain function and overall welfare. What makes this even more remarkable is how this understanding has evolved. 20 or 30 years ago, the focus was primarily on preventing negative behaviors like pacing or repetitive movements. Now, the science has shifted toward promoting positive experiences, creating opportunities for animals to express natural behaviors, make meaningful choices, and engage their minds in ways that mirror the complexity they'd face in wild environments. This scientific foundation explains why modern enrichment programs are so sophisticated and individualized. When you understand that you're literally shaping neural pathways and optimizing brain chemistry, you realize that generic approaches won't cut it. Each species has evolved different cognitive abilities, sensory specializations, and behavioral needs. A great ape's cognitive enrichment requirements are vastly different from those of a big cat or a marine mammal, just as their brains have evolved along different paths to solve different environmental challenges. The research has also revealed that timing and variety matter enormously. Just like human brains, animal brains adapt to routine and stop responding as strongly to familiar stimuli. This is why modern enrichment programs emphasize unpredictability, rotation of different items and challenges, and continuous innovation to maintain that crucial element of novelty that keeps neural pathways actively growing and adapting. Understanding this scientific foundation changes everything about how we evaluate what animals in human care actually need. It's not just about survival or even comfort. It's about providing the kind of complex, stimulating environment that allows their brains to develop and function the way evolution designed them to work. And as we'll see in the examples coming up, when zoos get this right, the results are absolutely extraordinary. All right, so we've established that enrichment isn't just feel-good fluff. It's grounded in serious neuroscience that shows how it literally rewires animal brains for the better. But you might still be thinking, okay, that sounds great in theory, but does it actually work in practice? Well, buckle up, because the numbers are about to blow your mind. Let me start with something that should make every skeptic sit up and pay attention. When researchers decided to systematically review the effectiveness of enrichment programs across the board, they didn't just look at a handful of feel-good stories. They analyzed 54 rigorous scientific studies spanning multiple species, different types of enrichment, and various welfare measures. The results? An overwhelming 90% of these studies demonstrated that enrichment actually works. We're not talking about marginal improvements here. The average effect size was 0.46, which in scientific terms means these are substantial, meaningful changes that you can actually see and measure. Think about that for a second. If 90% of studies showed that a new medication was effective, every doctor in the world would be prescribing it. If 90% of studies showed that a teaching method improved student performance, every school would adopt it immediately. Yet somehow, we're still having debates about whether enrichment is necessary for captive animals. The science has already answered that question definitively. But let's dig deeper into what these improvements actually look like, because the specifics are even more impressive. One of the most persistent criticisms of zoos has been the development of stereotypic behaviors. Those repetitive, seemingly purposeless movements like pacing or swaying that clearly indicate an animal is struggling psychologically. Well, properly implemented enrichment programs reduce these behaviors by an average of 53% across studies. Some of the most successful programs have achieved up to 75% reduction in these problematic behaviors. That's not just statistical noise, that's the difference between an animal that's clearly suffering and one that's engaging naturally with its environment. Now here's where the numbers get really shocking, and this ties back to that statistic I mentioned at the beginning of the video. When researchers compared the lifespans of animals in modern, well-managed zoos versus their wild counterparts, they found something that challenges everything most people believe about captivity. Are you ready for this? 84% of mammalian species actually live longer in zoos than they do in the wild. Let me say that again. The vast majority of mammals in good zoos outlive their wild relatives. This isn't a small difference we're talking about. For some species, the improvements are dramatic. Marine mammals provide some of the most striking examples. Over the past century, life expectancy for marine mammals in human care has increased up to 3.4 times compared to historical averages. Even more remarkable, first-year mortality, which is typically devastating for many species in the wild, has declined by 31% in zoo populations. These aren't just numbers on a spreadsheet. Each statistic represents thousands of individual animals living longer, healthier lives than they would have otherwise. And before you start thinking this is just because wild animals face predators and disease, let me clarify something important. These longevity improvements aren't solely due to veterinary care or protection from predators. The research specifically identifies enrichment programs as a key contributing factor. Animals in enriched environments show measurable improvements in immune function, stress management, and overall physiological health that directly translate to longer lifespans. Speaking of stress, let's talk about what the research reveals about cortisol levels. because this is where the science gets really sophisticated. Cortisol is often called the stress hormone, and you might assume that good animal welfare means keeping cortisol as low as possible, but it turns out the reality is much more nuanced than that. Healthy animals actually need cortisol fluctuations, what researchers call diurnal cortisol patterns, where levels rise and fall naturally throughout the day. Studies on great apes have shown something fascinating. While enrichment activities might initially cause a slight increase in cortisol, they preserve these healthy natural patterns and prevent the flattened cortisol profiles that indicate chronic damaging stress. It's like the difference between the healthy stress of exercise versus the harmful stress of chronic anxiety. Animals in enriched environments maintain cortisol rhythms that look remarkably similar to what you'd see in healthy wild populations, but the physiological benefits extend far beyond stress hormones. Research has documented enhanced immune function in animals receiving proper enrichment, including improved natural killer cell activity. Those are the immune cells that help fight off infections and even tumors. There's also evidence of reduced age-related immune system decline, meaning older animals in enriched environments maintain better health and disease resistance than those in barren conditions. Now, if you want to see these principles applied on a massive scale, look no further than conservation breeding programs. These numbers tell an incredible success story that most people never hear about. The California condor population hit a devastating low of just 22 birds in 1982. Today, thanks to intensive breeding programs that incorporate sophisticated enrichment protocols, there are 504 California condors alive. That's a population increase of over 2,200% in just 4 decades. Or consider the black-footed ferret program. These animals were actually declared extinct in the wild in 1979 before a small population was discovered in Wyoming. The breeding program has since produced over 11,000 individual ferrets, with hundreds successfully reintroduced to wild populations across multiple states. The key to these breeding successes: creating environments that promote natural behaviors through comprehensive enrichment programs. These conservation numbers matter because they demonstrate that enrichment isn't just about making individual animals happier. It's about maintaining genetic diversity and natural behaviors that are essential for species survival. When animals in breeding programs retain their natural instincts and behaviors through proper enrichment, their offspring are better prepared for eventual release into wild populations. The research also reveals something that should give every zoo visitor pause. Studies comparing public perception with actual welfare outcomes show that people significantly underestimate the effectiveness of modern enrichment programs. Meanwhile, the animals themselves are providing clear biological feedback that these programs work. Their stress hormones normalize, their immune systems strengthen, their lifespans extend, and their natural behaviors flourish. What makes these numbers even more impressive is that we're still in the relatively early stages of understanding optimal enrichment practices. As the field continues to evolve and incorporate new technologies and approaches, these already remarkable outcomes are likely to improve even further. The 90% success rate we see today might just be the beginning of what's possible when we truly understand and meet the psychological and physiological needs of animals in human care. Now that we've seen the science and the numbers proving enrichment works, let's get to the really fun part: seeing this knowledge in action. Because when you combine that solid scientific foundation with creative keepers and cutting-edge technology, you get innovations that would make Silicon Valley engineers jealous. And the best part? Every single approach is tailored to how different species actually think, move, and experience the world. Let's start with our closest relatives, the primates. Because what's happening with great ape enrichment will completely change how you think about animal intelligence. Picture walking into a zoo and seeing an orangutan casually swiping through an iPad, not just randomly poking at it, but actually navigating through painting apps with the kind of focus and intentionality you'd expect from a human artist. This isn't some one-off publicity stunt. Multiple zoos now provide touchscreen devices that great apes use for everything from creating digital artwork to playing cognitive games that challenge their problem-solving abilities. But here's what makes this so brilliant from a welfare perspective. Remember how we talked about the importance of choice and control in animal well-being? These iPad systems aren't forced activities. The animals can choose when to engage, what apps to use, and when they're done. Some individuals become obsessed with painting programs, creating abstract compositions that researchers are actually studying to understand color preferences and artistic decision-making in non-human minds. Others prefer puzzle games that challenge their spatial reasoning or memory. It's like having a personalized entertainment and enrichment system that adapts to individual personalities and preferences. Then there's Bristol Zoo's incredible modular puzzle maze system for gorillas. Imagine 12 interconnected cube-shaped modules that can be rearranged in countless configurations. The gorillas don't just solve these puzzles, they manipulate the actual structure, moving food rewards through complex pathways that require them to understand cause and effect relationships several steps ahead. It's like three-dimensional chess, but designed specifically for gorilla cognition and dexterity. And if that wasn't impressive enough, some facilities have installed something called the O-line system for orangutans, essentially a network of cables suspended 50 feet above ground that allows these incredible arboreal athletes to travel between enclosures, exactly as they would through forest canopies in Borneo or Sumatra. Watching an orangutan effortlessly swing hand over hand across these cables, making split-second decisions about grip placement and momentum, gives you a visceral understanding of why ground-based enclosures could never meet their psychological needs. Now let's shift gears and talk about big cats, because the innovations here tap into predatory instincts in ways that are both sophisticated and slightly terrifying. London Zoo has created what I can only describe as the ultimate hunting simulator, a 30-meter zipline system that suspends food items at varying heights and locations throughout the habitat. But here's the genius part. It's not just about getting the food. The system creates unpredictable movement patterns that trigger the same neural pathways involved in tracking prey, complete with the anticipation, stalking, and explosive pouncing behaviors that define these incredible predators. For African wild dogs specifically, keepers use the system to hide meat pieces throughout the habitat in ways that encourage pack hunting behaviors. The subordinate animals might catch the prey, but then the pack dynamics play out naturally as different individuals get access to different portions, just like they would after bringing down an antelope in the wild. It's social enrichment and predatory enrichment rolled into one sophisticated system. But wait, it gets weirder. You know how I mentioned that big cats have perfume preferences? This isn't just a cute anecdote. Scent enrichment for felids has become an incredibly precise science. Keepers now have access to over 30 different scent options, ranging from natural animal musks to commercial perfumes. And yes, Calvin Klein's Obsession consistently ranks as a favorite across multiple species of big cats. There's something about the specific combination of scent molecules that triggers intense interest and investigation behaviors. Tigers have been observed rolling in areas sprayed with their preferred scents, exhibiting the same kinds of scent marking behaviors they'd use to communicate territorial information in the wild. The technology gets even more advanced with 3D printed enrichment devices. Engineers can now design self-propelled balls with internal ballast systems that create completely unpredictable movement patterns. These aren't just toys. They're sophisticated behavioral triggers designed to activate specific neural pathways associated with hunting and play. The balls move in ways that no manufactured toy ever could, creating the kind of erratic, lifelike motion that makes a 400-pound tiger suddenly move with the focused intensity of a kitten chasing a laser pointer. Elephant enrichment showcases problem-solving challenges that would impress a team of engineers. Multi-port feeder cages require elephants to navigate their trunks through complex obstacle courses to access food rewards. We're talking about devices with multiple chambers, rotating components, and sequential unlocking mechanisms that demand the kind of spatial reasoning and fine motor control that elephants have evolved over millions of years of manipulating their environment with those incredible appendages. But the innovations go beyond cognitive challenges. Modern elephant habitats feature automatically refilling mud wallows with sophisticated plumbing systems that maintain optimal mud consistency for thermoregulation. Some elephants have figured out how to create their own custom wallows by manipulating water sources, demonstrating the kind of environmental engineering behavior you'd see in wild populations. There are even therapeutic mud beds positioned specifically to help older elephants with arthritis manage the transition between standing and lying down more comfortably. Marine mammals present unique three-dimensional enrichment challenges, and the solutions are equally creative. Underwater bubble systems create play opportunities that engage natural curiosity and provide sensory stimulation through both visual and tactile channels. Interactive sound systems respond to animal movement by producing different frequencies and patterns, essentially turning the entire aquatic environment into a massive musical instrument that responds to their presence and actions. What makes all of these innovations so remarkable is how they demonstrate that effective enrichment isn't about imposing human ideas of fun onto animals. It's about understanding how each species experiences and interacts with the world, then creating opportunities for those natural behaviors to flourish. The iPad painting orangutan, the perfume-obsessed tiger, and the problem-solving elephant aren't performing tricks for human entertainment. They're expressing cognitive abilities and behavioral preferences that evolution spent millions of years developing, finally given appropriate outlets in human care. This species-specific approach proves that modern zoos aren't one-size-fits-all operations anymore. They're becoming incredibly sophisticated environments, tailored to meet the psychological and physiological needs of each individual species. And as we'll see next, the technology behind these innovations is advancing faster than ever. Now here's where things get really exciting, because we're moving beyond just understanding what animals need and into the realm of how technology is revolutionizing our ability to deliver it. We've seen the species-specific innovations, but what's happening behind the scenes is a technological arms race to create smarter, more responsive, and more individualized enrichment systems. And honestly, some of these innovations sound more like science fiction than animal care. Let me start with something that perfectly illustrates how far we've come. Picture this scenario. A hornbill approaches what looks like a simple pine cone lying on the ground. But this isn't just any pine cone. It's been 3D printed with food-safe materials and has a tiny RFID chip embedded inside it. When the bird picks up this artificial pine cone and manipulates it in just the right way, it triggers a sensor that activates a conveyor belt system, which then dispenses a clay turtle containing a food reward at a completely different location in the habitat. This is called the Hungry Hungry Hornbill device, and it represents a fundamental shift in how we think about enrichment delivery. The bird isn't just finding food, it's engaging in a multi-step problem-solving sequence that requires tool manipulation, cause and effect understanding, and spatial memory to connect actions in one location with rewards in another. It's like a Rube Goldberg machine designed specifically for avian cognition, and the bird has to figure out how to make the whole system work. But that's just the beginning of what RFID technology is making possible. Animal vending machines, yes, you heard that right, allow individual animals to collect tokens scattered throughout their habitat, then exchange those tokens for food rewards at specific stations. Think about the cognitive complexity involved here. The animal has to understand that these objects have value, remember where the exchange stations are located, and make the connection between collecting tokens and receiving rewards. It's essentially teaching animals to use a primitive form of currency, which taps into the same cognitive abilities that wild animals use to evaluate resource distribution and make foraging decisions. What makes this technology so powerful is how it addresses one of the biggest challenges in traditional enrichment: the novelty problem. Remember how we discussed that animal brains adapt to routine and stop responding as strongly to familiar stimuli? Well, RFID systems can be programmed with virtually unlimited variations. The same physical token might trigger different rewards on different days, or require different combinations to activate. It's like having an enrichment system that never gets boring because it's constantly presenting new challenges and combinations. Now let's talk about computer vision and artificial intelligence, because this is where enrichment is getting truly futuristic. Imagine walking into a zoo where the exhibits are watching the animals just as closely as the animals are watching their environment. Motion-activated cameras equipped with facial recognition software can automatically identify individual animals and log their interaction patterns with different enrichment items. This is not just cool technology for its own sake, it's generating unprecedented data about animal preferences and behaviors. Here's a concrete example of how this works in practice. A gorilla named Coco approaches an enrichment device while cameras equipped with computer vision software automatically recognize her based on her unique facial features. The system logs that she's interacted with this particular device, how long she engaged with it, and whether she seemed interested or quickly moved on to something else. Over time, this creates detailed profiles of individual preferences that keepers can use to customize enrichment programs with scientific precision. But the technology goes beyond just passive observation. Motion sensors, the same type used in gaming systems like the Xbox Kinect, allow animals to control their environment through movement. Picture an elephant walking into a certain area and having colored lights automatically respond to her position, or moving in a way that triggers projected images on the walls around her. It's like turning the entire habitat into an interactive environment that responds to the animal's presence and movements. The applications get even more sophisticated when you consider how this technology handles the individual assessment that modern welfare science demands. Instead of keepers having to guess whether an enrichment item is effective, computer vision systems provide objective data about engagement time, frequency of use, and behavioral indicators of interest or stress. If an individual animal consistently avoids certain types of enrichment, the system can flag that for keeper attention and suggest alternatives based on the animal's documented preferences. Three-dimensional printing technology deserves special attention because it's completely revolutionizing how quickly and precisely enrichment can be customized. Traditional enrichment often meant adapting human-made objects or building custom items by hand, a time-consuming process that limited how specific designs could be. Now, engineers can design enrichment items with exact specifications for safety, durability, and behavioral triggers, then print them using food-safe PLA plastic materials that can withstand serious abuse from large animals. The modularity that 3D printing enables is particularly brilliant. Instead of creating single-use items, designers can create systems of interlocking components that can be combined in countless configurations. It's like having enrichment Lego blocks specifically designed for each species' cognitive abilities and physical characteristics. A modular system for primates might include components that require fine motor control and sequential problem-solving, while a similar system for elephants would incorporate elements designed for trunk manipulation and the kind of large-scale physical interactions that these massive animals naturally engage in. But here's what I find most impressive about these technological advances. They're not replacing the human element in animal care, they're amplifying it. Keepers still make the crucial decisions about what types of enrichment to provide and when to introduce new challenges. But now they have access to objective data about effectiveness, automated systems that can provide consistent stimulation even when staff are busy with other tasks, and the ability to create completely customized solutions for individual animals with unique needs or preferences. The safety features built into these technologies also represent a major advancement. 3D printed items can be designed with predetermined breakaway points that prevent dangerous fragments if an animal manages to damage them. RFID systems can be programmed with safety limits that prevent overfeeding or excessive reward dispensing. Computer vision systems can even monitor for signs of stress or abnormal behavior and alert staff to potential problems before they become serious welfare issues. What we're seeing is the emergence of truly responsive environments that can adapt to individual animals in real time, while providing the kind of complex, unpredictable stimulation that promotes healthy brain development and natural behavior expression. These aren't just high-tech versions of traditional enrichment. They represent a fundamental evolution in how we think about creating optimal psychological environments for animals in human care. And perhaps most importantly, these technologies are becoming more accessible and affordable every year, meaning that innovative enrichment approaches that were once limited to the most well-funded facilities are starting to spread throughout the zoo community, ultimately benefiting thousands more animals worldwide. All right, so we've covered the science, we've seen the numbers, and we've explored the incredible technology that's making all of this possible. But let me tell you something. None of this would mean anything without the real people working behind the scenes, dedicating their careers to transforming animal lives, one enrichment program at a time. These aren't just feel-good stories. They are documented case studies that show exactly how this science translates into measurable, life-changing outcomes for both individual animals and entire species. Let me start with a story that perfectly illustrates how passion and expertise can create something extraordinary. Meet Jessica Scheftel at the San Diego Zoo, and her background is going to surprise you. She wasn't always an animal welfare specialist. In fact, she started her career as a librarian, spending her days organizing information and helping people find what they needed. But something changed when she read about Coco, the famous gorilla who learned sign language and had a pet kitten. That story sparked something in Jessica that completely redirected her life. She went back to school to study physical anthropology, diving deep into understanding how our closest relatives think and behave. Today, she serves as the wildlife welfare specialist at one of the world's most prestigious zoos, and her approach to enrichment reflects both her analytical librarian background and her deep scientific understanding of animal behavior. Jessica's philosophy cuts straight to the heart of what modern enrichment is really about. Enrichment is behavior-based, she explains. Keepers determine the goal they want to achieve and the behavior they want to encourage, then provide an opportunity for the experience. But here's where Jessica's story gets really impressive. She's not just working with charismatic megafauna that grab headlines. One of her most successful programs focuses on mountain yellow-legged frogs, a species most people have never heard of, but that represents a conservation crisis in California. Working with her team, Jessica designed enrichment environments that recreate the rocky outcrops and waterfall systems these frogs would encounter in their natural Sierra Nevada habitat. The result? They are successfully breeding and releasing hundreds of these critically endangered frogs back into the wild every single year. This isn't just enrichment for its own sake. It's enrichment that's directly contributing to species survival in the wild. Now let me take you across the Atlantic to London Zoo, where keeper Luke Harvey is managing what might be the most successful African wild dog program in Europe. When Luke took over this program, the pack hadn't successfully bred in almost 80 years. Think about that for a moment. 8 decades without a single successful reproduction. That's not just disappointing. It's a conservation disaster for a species that's already critically endangered in the wild. But Luke understood something crucial that ties back to all that neuroscience we discussed earlier. African wild dogs aren't just predators. They're highly social, cooperative hunters whose entire psychological well-being depends on being able to express complex pack behaviors. So he designed an enrichment system that doesn't just feed them, it allows them to hunt together as a coordinated team. Remember that 30-meter zipline system I mentioned earlier? Luke uses it to create elaborate hunting scenarios where meat is suspended at varying heights and locations throughout the habitat. But here's the brilliant part. He doesn't just randomly hang food around. He creates blood trails, hides meat pieces in locations that require digging and climbing, and sets up scenarios where pack dynamics play out naturally. During one recent feeding session, Luke observed something remarkable. Selous, the subordinate male, was the one who successfully caught the prey. But then the pack's natural hierarchy kicked in, with pups being allowed immediate access while working in small coordinated teams to strip the carcass. The results speak for themselves. In 2015, Luke's pack successfully bred for the first time in nearly a century, producing 11 healthy pups. That single breeding success represents not just individual animal welfare improvement, but a significant contribution to the genetic diversity of the entire European population of this critically endangered species. Those pups are now adults, some contributing to breeding programs at other facilities, spreading the genetic and behavioral benefits of Luke's enrichment innovations across an entire continental network. But perhaps no single story better illustrates the long-term impact of enrichment than the legacy of Singapore Zoo's orangutan program. Let me tell you about Ah Meng, a Sumatran orangutan who lived from 1962 to 2008 and became something unprecedented in the zoo world, the first non-human special tourism ambassador, appointed by the Singapore Tourism Board in 1992. What made Ah Meng special wasn't just her longevity, though living to 48 years old is impressive for any orangutan. It was how she lived. Singapore Zoo pioneered something revolutionary in the early 1980s, the world's first free-ranging orangutan habitat in a zoo setting. Instead of confining these incredibly intelligent arboreal apes to traditional enclosures, they created elevated boardwalk systems that allowed orangutans to move freely through forest canopies while maintaining visitor safety through thoughtful architectural design. The Breakfast with an Orangutan program that launched in 1982 might sound like a tourist gimmick, but it was actually a sophisticated enrichment strategy that recognized orangutans' natural curiosity and social intelligence. Ah Ming and her companions weren't performing tricks. They were choosing to interact with humans on their own terms in an environment that allowed them to express natural behaviors while engaging in the kind of novel experiences that keep those neural pathways we discussed earlier firing at optimal levels. The program's success went far beyond individual animal welfare. Ah Meng became a global conservation ambassador, inspiring millions of visitors to care about orangutan conservation and directly contributing to funding for wild habitat protection in Borneo and Sumatra. When she passed away in 2008, the Singapore government held an official funeral attended by thousands of people. But her real legacy lives on in the dozens of orangutans who have thrived in the enriched environment she helped establish, many of whom have gone on to successful breeding programs that maintain genetic diversity crucial for species survival. These success stories share common threads that illustrate exactly what we've been discussing throughout this video. Jessica's frog program succeeds because it addresses species-specific behavioral needs through scientifically designed environmental enrichment. Luke's wild dog breeding breakthrough happened because he created opportunities for natural social and predatory behaviors to flourish. Ah Meng's extraordinary life was possible because she lived in an environment that challenged her cognitively while respecting her natural arboreal lifestyle. What makes these stories so powerful is that they represent just a tiny fraction of similar successes happening at facilities around the world. Every one of these programs started with the same scientific foundation we've explored, understanding what animals actually need psychologically and physiologically, then creating innovative ways to meet those needs through thoughtful enrichment design. These aren't isolated miracles or lucky accidents. They're the predictable results of applying rigorous animal welfare science, creative problem-solving, and dedicated expertise to the challenge of caring for wild animals in human environments. And as these approaches continue to spread throughout the global zoo community, thousands more animals are experiencing the transformative benefits of truly excellent enrichment programs. Now, let me share with you what might be the most revolutionary development in modern zoo animal care, something that's transforming not just how animals receive medical treatment, but fundamentally changing the relationship between animals and their caregivers. We're talking about a complete paradigm shift from restraint-based veterinary care to cooperative healthcare, and the implications go far beyond anything you might imagine. To understand just how dramatic this change has been, let me paint you a picture of how veterinary procedures used to work in zoos. Imagine you're a 400-pound Siberian tiger who needs a routine blood draw for health monitoring. In the old system, this would mean being shot with a tranquilizer dart, losing consciousness, being handled by multiple people while unconscious, then waking up disoriented and stressed in an unfamiliar recovery area. The entire experience would be traumatic, dangerous for both the animal and the veterinary team, and could create lasting fear associations that make future medical care even more challenging. Now let me show you what that same blood draw looks like in a modern facility using integrated training approaches. That same 400-pound tiger walks voluntarily to a specially designed area of his habitat, calmly extends his paw through protective barriers, and holds perfectly still while a veterinarian draws blood, all while the tiger is completely awake, alert, and choosing to participate in his own health care. No sedation, no stress, no force. Just cooperation based on trust and positive reinforcement training that has taught the tiger that medical procedures predict good things happening. This transformation didn't happen overnight, and it required completely rethinking how we approach the psychology of medical care. The foundation is something called protected contact training, which is exactly what it sounds like. Training that allows close cooperation between animals and caregivers while maintaining physical barriers that ensure everyone's safety. Think of it like having a conversation through a fence, where both parties can interact meaningfully while staying in their own safe spaces. But here's where the science gets really interesting, and it ties back to everything we've discussed about choice and control being fundamental to psychological well-being. In these training programs, animals always, and I mean always, maintain the option to participate or leave. The tiger choosing to present his paw for a blood draw could walk away at any moment. The elephant positioning herself for a foot examination could decide she's done and move to a different part of her habitat. This element of choice transforms what could be a stressful medical procedure into an enrichment activity that actually enhances psychological welfare. Let me break down how this progression works, because understanding the training process helps illustrate why it's so effective. It starts with basic relationship building. Keepers spend time near the animal, offering food rewards and positive interactions that create trust and positive associations with human presence. Then comes target training, where animals learn to touch specific objects or move to particular locations when asked. This might seem simple, but it's actually teaching the animal that they can control outcomes through their behavior, a fundamental psychological principle that enhances confidence and reduces anxiety. From there, the training builds systematically toward more complex medical behaviors. An elephant might start by simply lifting her foot when asked, receiving a food reward for cooperation. Over weeks or months, this progresses to allowing keepers to examine the foot, then to cleaning procedures, nail trimming, and eventually complex foot care that prevents the infections and structural problems that used to plague captive elephants. What makes this approach so brilliant is how it addresses the neurochemical aspects of stress and fear that we discussed earlier. Instead of flooding an animal's system with stress hormones through forced restraint, positive reinforcement training actually triggers the release of dopamine and other neurochemicals associated with reward and pleasure. The animal's brain starts associating medical procedures with positive experiences rather than trauma, creating a completely different physiological response to healthcare. The applications extend far beyond basic veterinary procedures, and some of the examples will absolutely blow your mind. At the Smithsonian National Zoo, Asian elephant Nai Lin participates in her own ultrasound examinations, standing calmly while veterinarians monitor her reproductive health through ultrasound imaging that would be impossible to obtain from a sedated animal. The image quality is better, the stress to the animal is eliminated, and the veterinary team can gather more comprehensive health information because they can observe the elephant's natural behavior throughout the examination. Marine mammals have perhaps embraced this cooperative healthcare approach most enthusiastically. Dolphins and sea lions routinely participate in their own blood draws, allow veterinarians to examine their teeth and breathing, and even position themselves for radiographic imaging. Some individuals have learned to present different parts of their bodies on command, essentially conducting their own physical examinations, while veterinarians observe and assess their condition. But here's what I find most remarkable about this integration of training and veterinary care. It's not just about making medical procedures easier. It's actually creating deeper, more trusting relationships between animals and their caregivers that enhance every aspect of daily life. When an animal learns that cooperating with humans leads to positive outcomes, that confidence and trust extends beyond medical situations into general husbandry, enrichment activities, and social interactions. Consider the psychological implications for a moment. These training programs are essentially teaching animals that they have agency over their own experiences, that their choices matter, and that cooperation with caregivers leads to beneficial outcomes. This kind of empowerment addresses some of the fundamental psychological challenges of captivity by giving animals meaningful control over important aspects of their daily lives. The welfare benefits extend even to species you might not expect. Nile crocodiles and gharials, animals most people would assume are impossible to train, have learned to participate in basic medical examinations and husbandry procedures. Large carnivores like lions and bears engage in protected contact training that allows safe interaction for everything from weight monitoring to dental examinations, all without the need for chemical restraint that could compromise their health or create negative associations. What's particularly exciting is how this approach is spreading throughout the global zoo community. Facilities that once relied heavily on sedation for routine medical care are discovering that investing in training programs not only improves animal welfare, but also enhances the quality of veterinary information they can gather. When animals are calm and cooperative during examinations, veterinarians can observe natural behaviors, obtain better diagnostic samples, and detect health problems earlier than would be possible with sedated animals. This revolution in veterinary care represents something much larger than just improved medical procedures. It's a fundamental recognition that psychological welfare and physical health are intimately connected, and that treating animals as active participants in their own care, rather than passive subjects, creates better outcomes for everyone involved. The tiger choosing to participate in his blood draw is not just making the veterinarian's job easier, he's exercising the kind of choice and control that promotes the neurochemical balance we know is essential for psychological well-being. Now, I know what you're thinking after hearing all these amazing success stories and cutting-edge technologies. This all sounds incredible, but there's got to be a catch, right? Well, you're absolutely correct. Creating world-class enrichment programs isn't just about having great ideas and scientific knowledge. The reality is that zoos face some serious practical challenges that would make even the most dedicated animal care professionals want to throw in the towel. But here's the fascinating part. These very challenges are actually driving some of the most creative and innovative solutions we've ever seen in animal care. Let's start with the elephant in the room. And I mean that literally. Budget constraints are probably the biggest obstacle facing enrichment programs worldwide, and when you're dealing with animals that can destroy expensive equipment faster than you can say boom or ball, this becomes a real problem. Picture this scenario. You've just spent $1,000 on a specially designed enrichment ball for your big cats, engineered to withstand incredible abuse and provide hours of mental stimulation. 3 days later, you walk into the habitat to find it completely destroyed, scattered in pieces across the enclosure like the aftermath of a particularly enthusiastic demolition project. This exact scenario plays out in zoos around the world on a regular basis. Large carnivores, with their incredible strength and natural drive to investigate everything through their teeth and claws, can turn even the most robust enrichment items into expensive confetti. Elephants, with their intelligence and trunk dexterity, become master escape artists who can dismantle enrichment devices with the precision of engineers, except they're not trying to preserve the equipment for future use. But rather than throwing up their hands in frustration, innovative keepers have turned this challenge into an opportunity for creative problem-solving. Many facilities now operate sophisticated rotation systems that maximize the utility of expensive enrichment items by cycling them between different animals and exhibits. One zoo might have 5 different big cat species sharing a collection of 20 high-end enrichment devices, creating a constant rotation that maintains novelty for the animals, while spreading the cost across multiple programs. Even more creative are the public engagement solutions that many zoos have developed. Amazon wish lists have become a surprisingly effective tool for involving zoo visitors directly in enrichment programs. People can purchase specific items that animals need, from puzzle feeders to sensory enrichment materials, creating a direct connection between public support and animal welfare. Some facilities have taken this a step further, creating adopt-in enrichment programs initiatives where individuals or groups can sponsor ongoing enrichment activities for specific animals or species. The safety considerations present an entirely different category of challenges that require constant balancing acts between innovation and prudent risk management. Every single enrichment item has to be evaluated not just for its effectiveness in promoting natural behaviors, but also for its potential to cause harm if things go wrong. This creates what you might call productive tension between pushing boundaries and maintaining safety standards that protect both animals and staff. Consider the complexity of designing enrichment for animals that keepers cannot share physical space with safely. When you're working with large predators or potentially dangerous herbivores like elephants or rhinos, every enrichment device has to be designed with the assumption that it might be weaponized, swallowed inappropriately, or broken in ways that create sharp edges or toxic materials. This constraint has actually driven incredible innovations in materials science and engineering design specifically for zoo applications. Veterinary oversight adds another layer of complexity that often frustrates keepers who see opportunities for enrichment that medical staff deem too risky. But this apparent obstacle has led to some of the most sophisticated, collaborative approaches in modern zoo management. Veterinary behaviorists, specialists who understand both animal psychology and medical safety, now work directly with enrichment teams to develop approaches that maximize behavioral benefits while minimizing health risks. This collaboration has produced enrichment protocols that are actually safer and more effective than what either discipline could develop independently. Perhaps the most complex challenge involves public perception and the constant balancing act between what's most effective for animal welfare and what looks appropriate to zoo visitors. This creates a fascinating psychological tension that most people never consider. The most effective enrichment often looks nothing like what the general public expects to see in a zoo setting. A tiger enthusiastically interacting with a cardboard box filled with scents might be experiencing optimal psychological stimulation, but visitors might interpret this as the zoo being too cheap to provide proper enrichment. Media scrutiny amplifies this challenge exponentially. News stories about animals playing with everyday objects like cardboard boxes or PVC pipes can generate public criticism that completely misses the scientific basis for these choices. This has forced zoos to become much more sophisticated in their educational messaging, explaining not just what they're doing, but why specific approaches are most beneficial for individual animals. The institutional culture challenges might be the most subtle, but also the most important. Risk-averse administrative approaches that prioritize avoiding any possibility of negative publicity can severely limit innovative enrichment programs. Some facilities struggle with institutional cultures that favor traditional, visually appealing exhibits over optimal animal welfare approaches that might look less impressive to casual observers. But again, these challenges are driving remarkable innovations in communication and education. Zoos are developing increasingly sophisticated ways to help visitors understand the science behind enrichment choices, from interpretive signage that explains behavioral goals to behind-the-scenes programs that show visitors how enrichment decisions are made. Some facilities now use social media platforms to document enrichment programs in real time, showing the immediate behavioral responses that demonstrate effectiveness even when the enrichment items themselves might look unconventional. The staffing and expertise challenges represent another area where limitations are spurring creativity. Developing effective enrichment programs requires specialized knowledge in animal behavior, psychology, engineering, and safety management, expertise that many facilities struggle to maintain with limited budgets. This has led to incredible collaborative networks where zoos share enrichment ideas, protocols, and even loan specialized staff for training programs at other facilities. Professional organizations have emerged specifically to address these challenges, creating standardized training programs, resource-sharing networks, and research collaboratives that allow smaller facilities to access the same level of expertise that was once limited to major institutions. The Animal Enrichment Consortium, for example, provides resources and training that enable zoos with limited resources to implement sophisticated programs based on the latest scientific research. What's most remarkable about observing these challenges in action is how they're forcing the entire field to become more innovative, collaborative, and evidence-based. Budget constraints are driving creative engineering solutions. Safety concerns are producing more sophisticated risk assessment protocols. Public perception challenges are creating better educational approaches. Staffing limitations are fostering knowledge-sharing networks that benefit the entire global zoo community. These aren't obstacles that are holding back progress. They're catalysts that are accelerating the development of more effective, more efficient, and more broadly applicable enrichment approaches than would ever have emerged without these practical constraints pushing innovation forward. Now here's where this whole conversation takes a turn that might surprise you, because everything we've been talking about, the brain science, the innovative technologies, the incredible training programs, All of that is really just the foundation for something much bigger. What we are actually witnessing is how individual animal welfare improvements create ripple effects that extend far beyond the boundaries of any single zoo, ultimately contributing to global species survival in ways that most people never even realize. Let me help you understand how this connection works, because it's not immediately obvious why a tiger playing with an iPad or an elephant solving puzzles should matter for conservation efforts happening thousands of miles away in wild habitats. The key is something called the Species Survival Plan, or SSP, which is essentially a sophisticated genetic management program that treats zoos not as individual institutions, but as interconnected nodes in a global conservation network. Think about it this way. Imagine you're trying to maintain a healthy human population, but instead of having millions of people to work with, you only have a few hundred individuals scattered across different locations around the world. Your success in maintaining genetic diversity and healthy reproduction would depend entirely on making sure those individuals remain as close to their natural state as possible, physically, psychologically, and behaviorally. This is exactly the challenge facing captive breeding programs for endangered species. Here's where enrichment becomes absolutely crucial for conservation success. When animals live in environments that promote natural behaviors and maintain psychological well-being, they're far more likely to breed successfully and raise offspring that retain the instincts and behaviors essential for survival. Remember those neuroplasticity benefits we discussed earlier? Well, it turns out that animals with properly functioning brains that have been stimulated and developed through appropriate enrichment, are significantly better at the complex behavioral tasks that successful reproduction requires. Let me give you a concrete example that illustrates this principle perfectly. California condors, those massive scavengers with 10-foot wingspans, were down to just 22 individuals in the entire world by 1982. The captive breeding program that has brought them back from the brink of extinction, we now have over 500 individuals, succeeded largely because enrichment programs maintain the complex social and foraging behaviors these birds need to survive in the wild. Condor chicks raised by parents who had access to appropriate enrichment learned essential skills like recognizing food sources, avoiding human contact, and navigating complex social hierarchies within condor flocks. Compare this to earlier captive breeding attempts that failed because birds raised in barren environments never developed these crucial survival skills. The enrichment programs didn't just make individual condors happier, they preserved the behavioral knowledge that an entire species needed to avoid extinction. But the conservation benefits extend even further than maintaining breeding populations, and this is where the research applications become really exciting. Animals in well-designed enrichment programs essentially become living laboratories that help us understand wild behavior patterns we could never study directly in natural habitats. When a zoo elephant uses tools to manipulate her environment, or when primates develop innovative problem-solving strategies, they're providing insights into cognitive abilities and behavioral flexibility that help conservationists design better protection strategies for wild populations. Consider how this research application works in practice. Field biologists studying wild orangutans in Borneo might observe tool use behaviors, but they can't exactly set up controlled experiments to understand how these behaviors develop or what environmental factors promote their emergence. Zoo-based orangutans participating in cognitive enrichment programs provide a unique opportunity to study learning processes, innovation, and cultural transmission in ways that directly inform conservation strategies for protecting wild habitat and managing wild populations. The educational impact represents another layer of conservation benefit that most people completely underestimate. Here's something that might change how you think about zoo visits. Research shows that visitors who observe animals engaged in natural behaviors, the kind promoted by good enrichment programs, develop significantly stronger emotional connections to those species and greater motivation to support conservation efforts. This isn't just feel-good speculation. Studies tracking visitor behavior before and after zoo experiences show measurable increases in conservation donations, volunteer participation, and lifestyle changes among people who witnessed animals actively engaging with enrichment activities. When visitors see a tiger demonstrating problem-solving abilities, or watch elephants cooperating to manipulate complex enrichment devices, they're not just being entertained. They're developing a deeper understanding of animal intelligence and behavioral complexity that translates into conservation support. But here's where the educational benefits get really sophisticated, and this connects back to all those challenges we discussed about public perception. Modern enrichment programs are actually changing how people think about the relationship between animal welfare and conservation. Visitors who understand that the cardboard box their favorite tiger is enthusiastically destroying represents cutting-edge animal welfare science are more likely to appreciate the complexity and importance of conservation work generally. The research contributions extend into veterinary and behavioral science that benefits wild populations directly. Training programs that we discussed earlier, the ones that allow cooperative medical care, generate unprecedented health data about endangered species. When zoo veterinarians can conduct detailed health assessments on calm, cooperative animals, they're building knowledge bases about normal physiological parameters, disease patterns, and health interventions that can be applied to wild populations facing similar challenges. Field veterinarians working with wild elephants in Africa now use anesthesia protocols and health monitoring techniques that were first developed and refined through cooperative care programs in zoos. The diagnostic knowledge that comes from examining healthy captive animals provides baselines that help identify disease outbreaks or environmental health threats in wild populations much earlier than would otherwise be possible. Perhaps most importantly, the integration of enrichment with conservation represents what scientists call the one-plan approach. The recognition that in situ and ex situ conservation efforts are not separate activities, but complementary strategies that strengthen each other. Animals maintained in excellent welfare conditions through comprehensive enrichment programs serve as genetic and behavioral reservoirs for species that might face catastrophic population crashes in the wild due to habitat loss, climate change, or disease outbreaks. The black-footed ferret program provides a perfect illustration of this integration. The 11,000 ferrets produced through captive breeding haven't just maintained genetic diversity. They've preserved the complex social and hunting behaviors that wild ferrets need to establish territories and reproduce successfully when reintroduced to prairie ecosystems. The enrichment programs that maintained these behaviors in captivity directly enabled the successful establishment of wild populations across multiple states. What makes all of this so remarkable is how it demonstrates that excellent animal welfare isn't just compatible with conservation goals. It's actually essential for conservation success. The neurological health, behavioral complexity, and psychological resilience that enrichment programs promote in individual animals directly translate into the kind of robust, adaptable populations that can survive and thrive when returned to wild habitats, or when wild populations need genetic reinforcement from captive-bred individuals. This creates a virtuous cycle where investments in individual animal welfare generate conservation benefits that extend far beyond any single institution or even any single species. The research knowledge, veterinary expertise, educational impact, and genetic management that emerge from excellent enrichment programs contribute to a global conservation infrastructure that's working to address biodiversity loss on a planetary scale. Understanding these connections helps explain why modern zoos aren't just places where people go to see animals. They're becoming integral components of a global conservation strategy that recognizes the interconnection between individual welfare, species survival, and ecosystem health. All right, so we've taken this incredible journey through the current state of zoo enrichment, from the fundamental neuroscience to the amazing real-world applications. But here's the thing that gets me most excited about this field. We're still just scratching the surface of what's possible. The innovations we're seeing today are going to look primitive compared to what's coming in the next decade, and the implications for animal welfare are absolutely mind-blowing. Let me start by helping you understand how artificial intelligence is about to completely revolutionize how we approach animal enrichment. Remember those computer vision systems we talked about that can recognize individual animals and track their interactions with different enrichment items? Well, that's just the beginning. We're moving toward AI systems that don't just observe and record. They actually learn and adapt in real time based on what they're seeing. Picture this scenario, and I want you to really think through the implications. An AI system is monitoring a group of chimpanzees throughout their day, using computer vision to track not just which individuals interact with which enrichment items, but also analyzing their facial expressions, body language, stress indicators, and social interactions. The system notices that one individual, let's call her Maya, consistently shows signs of increased engagement when presented with puzzle-based challenges, but quickly loses interest in purely physical enrichment items. Now here's where it gets remarkable. Instead of waiting for a keeper to notice this pattern and manually adjust Maya's enrichment program, the AI system automatically begins customizing her experiences in real time. It starts presenting her with increasingly complex cognitive challenges while reducing the frequency of physical toys that do not capture her interest. But it goes even further than that. The system recognizes that Maya's problem-solving peak occurs in the morning hours and begins timing the presentation of her most challenging puzzles to coincide with when her cognitive performance is naturally highest. This isn't science fiction. The foundational technologies already exist, and pilot programs are being tested at cutting-edge facilities right now. What we're looking at is the emergence of truly personalized enrichment systems that treat each animal as a unique individual with specific preferences, optimal learning times, and distinct personality traits. But let me help you understand why this represents such a fundamental shift in our approach to animal welfare. Everything we've discussed so far has been essentially reactive. We observe behaviors, design enrichment to address them, then evaluate whether our interventions worked. The future of enrichment is proactive, using predictive analytics to prevent welfare problems before they ever develop. Think about how this proactive approach might work in practice. Machine learning algorithms analyzing years of behavioral data from thousands of animals could identify subtle early warning signs that an individual is beginning to develop stereotypic behaviors or showing decreased engagement with their environment. Instead of waiting for these problems to become obvious to human observers, AI systems could trigger immediate environmental modifications, social interventions, or enrichment adjustments that redirect the animal's psychological trajectory before any welfare compromise occurs. The sophistication of these predictive systems is going to be extraordinary. Imagine sensors that monitor not just visible behaviors, but physiological indicators like heart rate variability, cortisol levels through non-invasive sampling, and even brain activity patterns through advanced imaging technologies. These systems would create comprehensive welfare profiles for individual animals that go far beyond anything human observation could capture, detecting subtle changes in psychological state that might indicate the need for enrichment modifications. Now let me introduce you to a framework that's going to guide much of this future development. It's called welfare through competence. And understanding this concept will help you grasp why future enrichment is going to be so much more effective than current approaches. The basic principle is that animals experience positive psychological states not just when their needs are met, but when they feel competent and effective in their environment. Traditional enrichment often focuses on providing stimulation or opportunities for natural behaviors, which is important but somewhat passive. The welfare through competence framework takes this further by ensuring that animals can develop mastery over their environment, experience genuine choice and control, and build confidence through successfully meeting challenges that are appropriately calibrated to their abilities. Future enrichment systems will incorporate what researchers call animal-computer interaction principles, where technology becomes a responsive partner in the animal's daily experience rather than just a source of stimulation. Think of it like the difference between watching television and playing an interactive video game. One is passive consumption, the other involves active engagement, skill development, and personalized challenge progression. Here's a concrete example of how this might work. An elephant's habitat could be equipped with ground-based pressure sensors, motion detectors, and interactive projection systems that respond to the animal's movements and choices throughout the day. When the elephant approaches different areas of her habitat, the environment could respond with appropriate sensory experiences, sounds, visual projections, or even scent releases that are calibrated to her documented preferences and current engagement level. But the system goes beyond just responding to the elephant's presence. It learns her patterns, preferences, and skill level, gradually introducing new challenges and experiences that are perfectly matched to her cognitive abilities and motivational state. If she's having a particularly interactive day, the system might present more complex problem-solving opportunities. If she seems to prefer quieter activities, it could offer more subtle sensory enrichments that don't require active engagement. The adaptive learning capabilities of these systems will be perhaps their most impressive feature. Instead of requiring human programmers to anticipate every possible scenario and response, machine learning algorithms will continuously refine their understanding of what each individual animal finds most engaging, challenging, and rewarding. Preference testing, which currently requires significant time and expertise from animal care staff, will become automated and continuous. AI systems will constantly present animals with subtle choices and track their responses, building increasingly sophisticated profiles of individual preferences that can guide enrichment decisions with scientific precision. But perhaps the most exciting development is how these technological advances will integrate with our growing understanding of animal cognition and emotion. We're moving toward enrichment systems that don't just provide stimulation, but actually support the development of emotional resilience, cognitive flexibility, and social competence in ways that mirror the challenges animals would face in complex wild environments. The shift from reactive to proactive welfare management represents a philosophical evolution that's just as important as the technological advances. Instead of designing enrichment to fix problems after they develop, future systems will focus on creating optimal developmental environments that promote psychological flourishing from the very beginning of an animal's life in human care. This proactive approach will be particularly transformative for young animals, where early enrichment experiences can have lifelong impacts on cognitive development, social skills, and emotional regulation. AI systems monitoring infant development could ensure that each individual receives precisely the right types and intensities of stimulation at crucial developmental windows, optimizing brain development in ways that set the foundation for a lifetime of psychological well-being. The integration of all these technologies and approaches will create something that we've never seen before in animal care: truly individualized welfare management systems that treat each animal not as a representative of their species, but as a unique individual with specific needs, preferences, abilities, and potential for growth. What makes all of this so remarkable is that these aren't distant possibilities. The foundational technologies exist today, and innovative facilities around the world are already beginning to implement early versions of these systems. Within the next decade, we're going to see enrichment programs that are more sophisticated, more effective, and more individually tailored than anything we could imagine just a few years ago. The animals benefiting from these future systems won't just have better lives. They'll have lives that are optimized for their individual psychology in ways that support not just survival, but genuine flourishing in all its complexity. So here we are at the end of this incredible journey, and I want you to take a moment to think about everything we've discovered together. When we started this conversation, I asked you to imagine a tiger solving puzzles and making choices about its own day. I told you that might sound impossible, but that it would completely change how you think about zoos. Now, after diving deep into the science, the technology, the real-world successes, and the future possibilities, I hope you're starting to understand that we haven't just been talking about better animal care. We've been witnessing nothing short of a complete scientific revolution in how humans understand and support animal minds. Let me help you see the bigger picture by connecting all the dots we've explored. Remember that fundamental neuroscience we started with? The research showing that enrichment literally rewires animal brains, promoting neurogenesis, optimizing neurotransmitter balance, and enhancing cognitive abilities? That wasn't just interesting academic information. That was the foundation that explains why every single innovation we've discussed actually works at the most basic biological level. When you see an orangutan painting on an iPad or an elephant solving complex engineering puzzles, you're not witnessing some kind of cute performance or entertainment. You're observing the direct application of cutting-edge neuroscience that recognizes animal brains as dynamic, adaptable systems that require complexity and challenge to function optimally. Every interaction with these enrichment systems is literally building new neural pathways and strengthening cognitive networks that mirror what would happen in the most stimulating natural environments. But here's what I find most remarkable about this scientific revolution. It's not happening in isolated laboratories or academic institutions. It's being implemented in real facilities, with real animals, generating measurable results that validate the theory with hard data. When we talked about that meta-analysis showing 90% of enrichment studies demonstrating positive effects, we weren't discussing abstract possibilities. We were looking at documented proof that this scientific approach consistently improves animal lives across different species, different facilities, and different types of challenges. The numbers tell a story that should fundamentally change how anyone thinks about modern animal care. That 84% figure, showing that the vast majority of mammals live longer in well-managed zoos than in the wild, represents thousands of individual animals whose lifespans have been extended through the application of scientific welfare principles. The 53% average reduction in stereotypic behaviors means thousands more animals who have moved from psychological distress to natural behavioral expression through properly designed enrichment programs. These aren't statistics. They're individual success stories multiplied across a global network of facilities that have embraced evidence-based animal care. Every percentage point represents real animals living better lives because humans took the time to understand what they actually needed psychologically and physiologically, then developed creative ways to meet those needs. The technological innovations we explored demonstrate something equally important: that this scientific revolution is accelerating rather than slowing down. When we discussed RFID systems creating multi-step cognitive challenges, or AI systems providing personalized enrichment experiences, we were seeing how human ingenuity can amplify scientific understanding to create solutions that would have been impossible just a few years ago. But technology alone doesn't explain the transformation we're witnessing. The real revolution lies in the fundamental shift in how we think about the relationship between humans and animals in care settings. That cooperative veterinary care we discussed, where tigers voluntarily participate in their own blood draws and elephants position themselves for ultrasound examinations, represents a complete philosophical evolution from dominance-based management to partnership-based care. This partnership approach recognizes something profound that connects back to that contrafreeloading research we discussed early on. Animals don't just want their basic needs met. They want agency, choice, and the opportunity to exercise their cognitive abilities in meaningful ways. When we create environments that provide these opportunities, we're not just making animals happier in some vague, emotional sense. We're supporting the healthy functioning of psychological systems that evolution spent millions of years developing. The conservation implications we explored show how this individual welfare revolution creates benefits that extend far beyond any single animal or facility. When enrichment programs maintain natural behaviors and psychological resilience in captive populations, they're preserving the knowledge and skills that entire species need to survive in an increasingly challenging world. The California condor recovery, the black-footed ferret program, and countless other conservation successes demonstrate that excellent individual animal care and species conservation aren't competing priorities. They're mutually reinforcing strategies. Perhaps most importantly, this scientific revolution is changing how people understand the role that well-managed zoos can play in addressing global conservation challenges. When visitors see animals actively engaged with sophisticated enrichment systems, they're not just being entertained. They're witnessing demonstrations of animal intelligence, behavioral complexity, and psychological needs that build the kind of emotional connection and scientific understanding that supports broader conservation efforts. The educational transformation happens at multiple levels. Children who grow up seeing animals as intelligent, capable individuals with preferences and personalities develop fundamentally different relationships with wildlife and conservation issues than those who see animals as simple, passive creatures. Adults who understand that cardboard box destruction represents cutting-edge welfare science are more likely to appreciate the complexity and importance of conservation work generally. But let me bring this back to something personal, because I think that's where the real transformation happens. The next time you visit a zoo, and I hope you will visit one after learning about all of this, you're going to see everything differently. That tiger investigating a scent-marked area isn't just sniffing around randomly. He's engaging in the same territorial assessment behaviors his wild counterparts use to gather crucial environmental information. The elephant manipulating objects with her trunk isn't just playing. She's exercising cognitive abilities that are being maintained and developed through scientifically designed challenges. You'll recognize the computer vision systems quietly monitoring animal behavior in the background, the carefully designed choice points that allow animals to control their own experiences, and the sophisticated rotation systems that maintain novelty and challenge. You'll understand that the keepers you see aren't just feeding animals and cleaning habitats. They're implementing complex welfare protocols based on the latest scientific understanding of animal psychology and cognition. Most importantly, you'll recognize that the animals themselves are not just surviving in human care. They're demonstrating that with proper understanding and appropriate environments, they can genuinely thrive in ways that support both their individual well-being and the survival of their species in an increasingly uncertain world. This scientific revolution in zoo animal care represents something larger than just improved welfare practices. It's proof that when humans apply rigorous scientific thinking to understanding and meeting the needs of other species, we can create relationships and environments that benefit everyone involved. The enrichment programs transforming animal lives today aren't just better animal care. They're demonstrations of what becomes possible when we combine scientific knowledge, technological innovation, and genuine respect for the complexity and individuality of animal minds. That tiger solving puzzles and making choices about his own day is not just possible. It's happening right now in facilities around the world as part of a scientific revolution that's transforming how we understand what it means to care for animals in the 21st century.